Hey guys, alright, so quick video in my absence, simplifying radicals, so mostly review. We're going to do a couple problems that are preview of what we're going to be doing in class tomorrow. So take a minute and copy down the title and these three problems, and then I will ask that the substitute pause because you should be able to do all three of these problems. So I'm going to say pause for like maybe 3 minutes or 4 minutes right now so that the students can copy this down and try and solve these 4 problems. Okay, so hopefully you had time, and if not, then it's a good thing we're reviewing because it probably means that you're a little rusty. So remember that when we're simplifying square roots, we're looking for a perfect square that goes into the number and the variable. We'll talk about the variables in a minute. So if you still need your list of perfect squares, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and so on. If you need it to be longer, you'll figure it out as you go. But we want to know which one of these numbers goes into that number evenly. So I'm sure you all can see that 25 goes in, right? So I'm going to break this up. Actually, let me color code this for you. I'm going to break this up. The perfect square that I'm using is 25. And 25 times 2 is what makes 50. And then now x is just x. There's no perfect square that goes into that. That's not anything times itself. So we're just going to leave the x hanging on for the ride underneath the radical. And then now we don't show this step very often anymore because we've been doing this so much. But what we're looking at is we want to know what the square root of 25 is, and then the square root of 2x. And we all know the square root of 25 is 5. And then we don't know the square root of 2 or x, so we leave it like that. So hopefully you got that one right. Now the next two, I'm going to guess you got the number part right, and then maybe some of you struggled with the variable part. So let's talk about that. So what perfect square goes into 8? We can clearly see that it's going to be a 4. So we have a radical. 4 goes evenly into 8 from my list here. 4 times 2 makes 8. And then I can break this y up. So that also has a perfect square. We got to go back to, that might have been 2 units ago. Whoops, sorry. Don't write that down. I'm getting ahead of myself. There is a perfect square in there. So y to the third is the same as y squared times y to the first using our exponent properties, and now that is a perfect square, y squared. So what can come out? So again, if you want to break it up like this, that's totally fine, but I think the majority of you are pretty good because we've been doing this so much that you can jump straight from here to here and skip a step. So the square root of 4 I know is 2. The square root of y squared, remember we're asking ourselves what times itself equals y squared? Well, y times y. So that's going to come out as well. And then I don't know the square root of 2 without a calculator. So I'm going to leave that under the radical. And then this is not a perfect square, so that stays under the radical as well. And that's my answer. Okay? So 5/12. So yes, oh my gosh, it's so big. What am I going to do? Maybe you can think of a perfect square that goes in, or maybe you can't. So that's why I left some space over here. So if you know what from this list goes in evenly, or maybe we're going to have to extend that list out, go for it. Totally fine. But if you're stuck, let's work it out. So 5/12, I'm going to do kind of like a number tree. So 2 clearly goes in because it ends with an even number, right? 2 goes into 5 how many times? 2, yeah. So that would be 4. So I have a 1 left over, so 11. 2 goes into 11 5 times. I have a 1 left over, so 12, 256. Okay? And then maybe you're still stuck, so that's okay. Let's break it up again. Maybe you're okay and you're seeing something here and maybe you're not. So let's keep going. Again, ends in an even number, so 2 goes in. 2 goes into 2 once. 2 goes into 5 twice with a 1 left over, so it would be 16. So then 2 goes into 16 8 times, and I can keep going. So 2 goes in, 64 times? Oh, there's a perfect square, 64. Okay? So this is a perfect square right here. That's on my list. Well, that would be the next one, right? 7 squared, 8 squared. And then I also see that this is 4, so that would be a perfect square as well. So 2 times 2 times 2 times 64 makes 512. So I'm going to write that as a 4 times a 64 times that 2 right there. So I got this 4 right here, and I've got the 64, and I've got the 2. And then z to the 4th can be written as z squared. Hopefully you remember your properties of exponents from a while back. And that's all under a square root. So then a lot of stuff can come out. Square root of 4 is 2. Square root of 64 is 8. Square root of z squared, what times itself equals z squared? That's z. So each of those becomes a z. And then the only thing stuck inside is the 2. The only thing that I don't know the square root of is a 2. Square root of 2 I would need a calculator for. So when I multiply the coefficient, 2 times 8, 16, z times z, z squared, and then square root of 2. Okay, so that was review. We've done that many times since the unit that we learned that in. We're going to use that in our next lesson. So we're going to see things like this. So we want to simplify the square root. Now, the biggest mistake that people make is, let me do it off to the side because I'm not going to have space to do this if I show you this mistake over here. So this is what people do, and it makes me want to cry. Oh, but why not? Why can't I do that? 10 divided by 20 is 1/2. Well, how is that 10 attached to the square root of 50? It's attached with addition, right? So if you do this, you're telling me that division and addition undo each other. Let me say that again. If you cross these off, you're telling me that division and addition undo each other. I know you all know that that is not true. I know that. I have every confidence that you know that is not true. What division and multiplication, right? So here's what we should do. We're going to break up the 50. So what perfect square goes into 50? I know you all know it because we already did it. 25 times 2. So the 25 is going to come out as a 5, and I don't know what the square root of 2 is. Okay? I don't think I gave myself enough space, but I'll make it work. All right. Now, the numerator has a common factor. These numbers that are not under the radical, I can take a 5 out. And then I'm left with, when I take a 5 out of 10, I'm left with 2 plus a 1, right? I'm not going to waste my ink. There's an invisible 1 in front, over 20. Okay? Let me... Now, how is that 5 attached to that parenthesis? Multiplication and division undo each other, so I can reduce the 5 and the 20 to 1 and 4. So on top, I'm not going to write that 1, right? That's a waste of ink. So I have 2 plus rad 2 over, the bottom became 4, and I'm done. I cannot reduce that 2 and that 4 because, again, it's attached with addition. Okay? All right, so maybe pause it for a second just to let them soak that in and copy it down if they need like 30 seconds or so. All right, so let's look at this one. We're going to do the exact same steps that we did over here. So we're going to write 8 plus, and we're going to break up that 20. So take a second and think about what goes into 20. We haven't done that one yet. So perfect square would be 4 times 5. We don't want 2 times 10 because neither of those are perfect squares, right? We want a perfect square. And then the square root of 4 is 2. And the square root of 5 has to stay. We don't know the square root of 5. So again, notice I didn't reduce those because it's attached with addition. We need to get it to be attached with multiplication, okay? Now the numerator has a common factor. These numbers that are not in the radical, I can take a 2 out, and I'm left with 4 plus 1 square root of 5, right? And again, I'm not going to waste my ink on the 1. So I took a 2 out, I'm left with 4. I took a 2 out, I'm left with invisible 1, okay? Now again, this 2 is attached with multiplication. So, and multiplication and division undo each other. So I can reduce, and I'm left with 1 times 4 plus the square root of 5 over 3. Okay? All right, so we're going to see this tomorrow, actually at the end of the problems that we're doing. So I'm just giving you a little bit of a preview because those problems are a little bit long, and I don't want to teach everything all in the same day. So you have, or you will have in a minute, a worksheet with a bunch of review of simplifying radicals, and we're going to add these 4 problems onto the back. So if the substitute could pause this when I'm done talking so that the students can copy these 4 problems. So these 4 problems are additional homework problems in addition to the Kuto software simplifying radical expressions worksheet. So you have 1 through 14 on the front of that worksheet, and then you're going to do 1 through 4 these problems on the back. All right, so copy those down, and I will see you guys tomorrow. Have a good day. Go ahead and pause it now, please.